Imagine uncovering a secret hidden within one of the most iconic paintings of the 20th century, only to realize it's now off-limits forever. That's exactly what happened when scientists recently identified a rare blue pigment in Jackson Pollock's No. 1A 1948, a masterpiece that epitomizes his revolutionary drip and splash technique. But here's where it gets controversial. The pigment, known as manganese blue, has been discontinued for decades due to environmental and health concerns. So while we now know what Pollock used, replicating it today is practically impossible. And this is the part most people miss. The discovery isn't just about satisfying curiosity. It's a game changer for art conservation. Pollock, a trailblazer of abstract expressionism, was famous for his chaotic yet deliberate approach to painting. His works, like No. 1A, are a whirlwind of colour and movement, with ropes of paint, drips of black, and pools of white merging into a layered, dynamic composition. While researchers had previously identified the red and yellow pigments in his palette, the vibrant blue remained a mystery. Until now. Using laser spectroscopy, a technique that examines matter at the atomic level, scientists confirmed the blue pigment as manganese blue, a turquoise-like colour first patented in 1935. Their findings were published in the journal PNAS, marking the first definitive evidence of Pollock's use of this now obsolete pigment. But why does this matter? Pigments like manganese blue, chemically known as barium manganate 6-sulfate, are the building blocks of colour in art. Manganese blue in particular was a favourite among artists until the 1990s, when it was phased out due to its harmful effects. Interestingly, while the pigment itself is gone, the hue it creates, a specific shade of blue, can still be achieved by mixing other pigments. For example, combining a blue and yellow pigment produces a green hue, not a green pigment. This distinction is crucial. Pigments are chemicals, while hues are the colours we perceive. The chemistry behind manganese blue's unique colour is equally fascinating. According to Edward Solomon, a chemist from Stanford University, the pigment's blue shade comes from the way its molecules absorb light. Each molecule contains a manganese ion surrounded by 4 oxide ions. When light hits the pigment, it causes an electron to jump from the oxide ion to the manganese ion, absorbing purple and green light and reflecting the blue we see. But here's the bigger question. Why go to such lengths to identify a pigment that's no longer in use? The answer lies in conservation. Knowing the exact chemical composition of a pigment helps conservators protect artworks from environmental damage. Many pigments, including manganese blue, are sensitive to light, UV radiation, and humidity. Without this knowledge, conservation efforts could inadvertently harm the artwork. For instance, certain treatments might react badly with specific pigments, leading to irreversible damage. That's why Abed Haddad, a conservation scientist at MoMA, urges artists to document the pigments they use, a small act that could save future masterpieces from deterioration. But here's the controversial part. Should we even try to recreate discontinued pigments like manganese blue? Some argue that preserving the original materials is essential for authenticity, while others believe modern alternatives are necessary to keep art alive. What do you think? Is it worth risking environmental harm to replicate historical colours, or should we focus on preserving what we have? Let's debate this in the comments. Your perspective could spark a whole new conversation about the future of art conservation.